So this unit has two main parts to it. First part, we're going to be working with the Pythagorean Theorem. We'll be working with volume, but for right now, we got this. All right, so start with, in a right triangle, the two sides adjacent to the right angle, those are known as the legs. Adjacent means they're the ones touching the right angle, so they're the ones that make the right angle. When we work with the Pythagorean Theorem, those legs are going to be known as side A and side B. Board ain't letting me write. Well, that's no good. All right, so try it again. We got side A, side B. It does not matter which one's A, which one's B, as long as it's the two sides that make the right angle. The side opposite from the right angle, so the side not touching it, that is called the hypotenuse. So when we work with these right triangles, they have to be right triangles, we have two legs and a hypotenuse. The hypotenuse over here, that's also going to be side C as we work with these. And the hypotenuse is always going to be the longest side. So, you got your three sides for the right triangle. Hypotenuse has to be the longest of the three. All right, so basically what we have then, we had a right triangle and freezing again. All right, so had the right triangle, long time ago, a guy named Pythagoras was kind of studying it, looking at it. He realized if he's labeling them A, B, C, what he could do is he could take each one of those sides and kind of put a square on it. Where square A, the side length on the square is the same as the leg there. Square B squared, side length is that leg. C squared, that square, the side length is the hypotenuse. And what he found was these two smaller ones would be equal to the area of the bigger one. So just to show, we'll use some numbers. So if I got 3, 4, and 5, if the side lengths of my triangle are 3, 4, and 5, I find the area for these squares, length times width, so 4 times 4, that's 16. 3 times 3, that's 9. My picture's not exactly a scale or anything, but we get the idea, right? Y'all, what's 5 times 5 then? 25. What's 16 plus 9? 25. And that's, what he discovered or what he found with that. So, Pythagorean Theorem, what that looks like is A squared plus B squared equals C squared. And we'll get that filled in with the next section. So what it tells us, Pythagorean Theorem tells us how the side lengths of right triangles are related. What's it mean if we have a right triangle? 9-degree angle. So they have to be right triangles for this. If it's not a right triangle, Pythagorean theorem doesn't work for it. In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So like we said, we get a squared plus b squared equals c squared. All right, so the way this works is actually going to be a little bit easier than that even. We'll get to that in just a second on how to do these. These triangles, label all four of them with their side lengths, A, B, C. All four triangles, we need them labeled A, B, C. Yeah, we got A, B, and C there. A and B make the right angle, so that's what we want. Second one's I. Second one's a little trickier. A, B, C, that's correct. They got that one kind of turned a little differently, so that makes it maybe a little bit tougher. Third one, Keller. Yeah, and the last one, Eric. That right side, you're probably going to have to squeeze in there a little bit, out of space a little bit there. Nope, that one's incorrect. Taquan. A and B need to make the right angle. All right, so you see on every one of these, we got A and B are the sides that make that right angle. C, our hypotenuse, does not touch the right angle. Everybody clear on that? Everybody see what I'm talking about? So sometimes they turn them differently. You got to be able to identify which one's a leg, which one's a hypotenuse. Because your right angle's right here. All right, so I need you, where there's space on your sheet, to write this down. If we are trying to find a hypotenuse, what you need to do on the calculators, and this works a lot better with the yellow ones than it does with Desmos. What you're going to do is you're going to take the square root of a squared plus b squared. So if we go back to that 3, 4, 5 triangle, what we're doing is we're taking squared. All right, so turn on your calculator. All right, so what you have to do this, And I'll show you how to do it on Desmos later. But like I said, I think this is an easier one with the yellow calculators, okay? So you hit the second button, and then you hit the button that says x squared. It's up and to the left of the 7. And it should give you the square root symbol, okay? Then since we're doing 3 squared, 4 squared, you're going to press 3. Then you press x squared again. Then you press plus. Then you press 4. And you hit x squared again. And once you have that in, you hit enter. It should give you 5. Anybody not get 5? Everybody follow how that works? Relatively easy to enter in once you get the hang of it, okay? One thing to notice. On these calculators, the line is over the top of it the whole time, right? If you accidentally get out where the line's not over the top, you probably need to start over or go back so the line's on top. Now, if we're trying to find a leg, so if we're trying to find A or B, what we are going to do is the square root of c squared minus b squared, or the square root of c squared minus a squared. Like I said before, it doesn't matter which one's A or which one's B. But you'll notice what letter comes first in that square root? C is coming each time. C has to be first. All right, so let's try it out. If we had, let's go with, we got 3 and 5. That's the triangle we had. So you do second x squared, square root symbol. The hypotenuse has to go first. So we're putting 5 squared minus, then enter, should give you 4, right? 4 hypotenuse, you add. That's the first one. If you're trying to find the hypotenuse, you are adding. If you are trying to find a leg, that is when you are subtracting. When you are subtracting, the bigger number has to go first. If you don't put the bigger number first, your calculator is going to give you an error. All right, everybody follow? Everybody got that? All right, so let's look at this. These two here, go ahead, get an answer for each of those. It's number 2, number 3. Ethan, what you got for number 2 here? 25 is correct. Y'all, those are legs. They're both touching the 90-degree angle. So to find the hypotenuse, we're going to add those up. So you got the square root of 24 squared plus 7 squared. Number 3 here. Keegan, what'd you get? Specific. Corey? No. A little bit different on these. We're going to have to be a little more specific. Nevaeh? 13.9. All right, so still trying to find the hypotenuse. So we are going to add those up. All right. For Pythagorean theorem, there are certain numbers you get what's called or what's known as a Pythagorean triple, where all three of the numbers are whole numbers. There aren't a ton of numbers that work out that way, though, okay? The majority of them are going to be like this one here. You know, we got 25 exactly right there. For number 3 here, you got other stuff, right? Well, there's a reason on already I had y'all working on rounding to make sure. We're going to have to round a lot on these. So when we're rounding, we want to go to like the 10th spot for these. So that means you need to look at the one after it. That should become 13.9. Everybody kind of follow on that? All right, flip it over. Try those 3. Number 5 here. Aubrey, what'd you get? 8. No? Oh, I said number 5. You're right. My bad, Aubrey. I meant this one, but I meant number 4, but I did say 5. So that'd be square root of 10 squared minus 6 squared. That does give you 8. All right, let's do the one I meant to say. Number 4 here. Keller, what you got? 12's correct. So we got the square root, 13 squared minus 5 squared. We're trying to find hypotenuses on this one. Hunter, what you got for 6? No? 17.9. All right, all 3 of these, we're trying to find a leg. We're trying to find one of the sides touching the right angle. So we need to subtract. Square root of 20 minus 16 squared. That gave us 17.9. You added. Is it super difficult? No. You do have to be careful whether you're looking for a hypotenuse or looking for a leg. That's the only big difference each time. If you're looking for a hypotenuse, you're adding them together. You got to subtract. Otherwise, it's a lot of doing the same thing over and over.